Hello, my name is Wyatt Rabita, and this is my Physics 2212 Lab 3 presentation on circuits. Introduction. The purpose of this lab is to observe the interactions between different parts that are used to construct simple circuits. The materials for this lab are two 1.5 volt batteries, clip wires, 10 ohm and 330 ohm resistors, a multimeter, a 1 Faraday capacitor, 10 ohm and 20 ohm light bulbs, and the Colorado FET circuit construction kit. Fundamental physics principles for this lab are Ohm's law, which states voltage is equal to current times resistance, and the node and loop rules. The node rule states the sum of currents flowing into a node must equal the sum of currents flowing out of the same node. And the loop rule states that the sum of all electric potential differences is zero in a contained loop. Initial conditions of the lab. The system is the circuit and the surroundings are everything else. This is what our table's circuit looked like, because our table did not have 100 ohm and 47 ohm resistors. We had to use 10 ohm and 330 ohm resistors. Prediction. Predict the currents I1 and I2 that would be measured by the two ammeters. Just to note, this is not the actual circuit we made. This is in response to the example series circuit. V is equal to IR, meaning that I is equal to V over R, or 3 volts over 147 ohms. Therefore, I is equal to 0.0204 amps. By modeling the circuit in the PHYS simulator, we can read that the ammeters both display a value of 0.02 amps, meaning the prediction was right. Assessment in real life. Our prediction for the real-life model is a little different, since the resistors we used had values 10 ohms and 330 ohms. The predicted value of I ended up being 0.00882 amps. When we measured the circuit using the multimeter at setting 200 microamps direct current, the current was 8.3 amps. When the connections of the multimeter were reversed, the reading became negative. When the multimeter was on the voltmeter setting, the current recorded went down, almost reaching exact zero. This is because the voltmeter acts like a huge resistor itself. The reading on the voltmeter was 2.7 volts because of the batteries losing voltage over time. Potential differences. Theoretically, the sum of all potential differences in a circuit should be equal to zero, as established by the loop rule. Thankfully, this holds up in the real-life experiment. 2.7 plus 0 minus 2.7 plus 0 is equal to 0. The graph of potential. When modeling with the graph, it becomes clear that the loop rule is true in this scenario. When we attach the voltmeter to the circuit to measure voltage, the circuit remains the same because the voltmeter is placed in parallel, and the electrons travel along the path of least resistance. Ammeter in parallel. If we place the voltmeter over the 330 ohm resistor, and then replace the voltmeter with an ammeter in parallel to the resistor, the current will flow through the ammeter, as it has much less resistance than the voltmeter. RC circuit. This part of the experiment involves a circuit made up of the two batteries from before, a 1 Faraday capacitor, and two interchangeable light bulbs, one of 10 ohm resistance and one of 20 ohm resistance. Here are the test results from the RC circuit. To charge the capacitor with the 10 ohm light bulb, it took 40 seconds. To charge the capacitor with the 60 seconds. And to discharge the capacitor, it took 8 seconds and 16 seconds for the 10 ohm and 20 ohm light bulbs respectively. Potential sources for error. Number 1. The parts of the circuit kit we used in lab may have been used and worn down already, like the batteries for example. Number 2. We did not have the necessary resistors to conduct the experiment with 47 ohm and 100 ohm resistors. And number 3. Timing with videos may have led to inaccurate results concerning capacitor charge and discharge time. Extra question. What if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? The capacitor would charge instantly, the flow of electrons. In real life, this would not happen because all circuit elements have resistance, even if it becomes negligible in calculations.